This is the Unit 5B Pre-AP Retake practice. So looking at these first two questions, what we're doing here is we're dividing. Now what we're dividing by here in both of these is something that is squared. So we're dividing by a quadratic. The only way to divide a polynomial by a quadratic is by doing long division. So what I'm dividing by, and this time it's x squared plus 5, is going to be on the outside. Anytime you skip a term, you need to put the placeholder there. So I have x squared plus 0x plus 5. And then what I'm dividing is x power 4 plus x cubed minus 6x minus 4. Note, I'm missing an x squared term, so you need to have a 0x squared in there. So x power 4 plus x cubed plus 0x squared minus 6x minus 4. Now when I'm doing long division, to start with, all I need is all I care about is these first terms. So what do I need to multiply x squared by so that it gives me x to a power of 4? That's going to be x squared. And then I do that multiplication. I multiply x squared by x squared, and it gives me that x to the power of 4. But I also multiply x squared by all parts that are in front here, every single part of it. So not only do I have x power 4, but I then have plus 0 x cubes, and then plus 5 x squareds. And in long division, you are subtracting. So I have x power 4 minus x power 4, those cancel. Then I have x power 3 minus 0 x cubed. So that leaves me with x cubed. Then I have 0x squareds minus 5x squareds. That's going to give me negative 5x squared. And then you bring down your next term. So I bring down the minus 6x. And you go again. Going from x squared, what do you need to multiply it by to get to x cubed? Well, that's just x. So plus x up there. And I'm going to multiply that x by all parts here. So that gives me x cubed plus 0 x squared plus 5x. And again, I'm subtracting these. So x cubed minus x cubed, that cancels. Negative 5x squared minus 0x squareds is still just negative 5x squareds. And negative 6x minus 5x, negative 6 minus 5 is negative 11x. And I bring down that negative 4. One more time. To get from x squared to negative 5x squared, I need to multiply by negative 5. So I'm then going to multiply all of those terms by negative 5. So x squared times negative 5 is negative 5x squared. The 0x times negative 5 is going to give me 0x. And then 5 times negative 5 is negative 25. I subtract those. So I have negative 5x squareds minus negative 5x squareds. Well, when I subtract a negative, I'm really adding. So those cancel. Negative 11 minus 0 is negative 11x. And then negative 4 minus negative 25, again, would be negative 4 plus 25. That's going to be positive 21. Now, I don't have anything else to drop down, nor is there anything I can multiply x squared by to get to negative 11x with a degree lower. So this is as far as I can go. So when I have my answer, it's what I had up here. So it is x squared plus x minus 5, and then plus this that I had left over, that is my remainder. That's going to go in my numerator, so negative 11x plus 21 over what it was I was dividing by, x squared plus 5. So the quotient of this problem is x squared plus x minus 5 plus negative x plus 21 over x squared plus 5. So in question 2, we're going through the same process. So what I'm dividing by, so I've got x squared plus 0x, because I don't have that middle term, minus 3. That's what I'm dividing by. And what I'm dividing is this 3x cubed minus 2x squared plus 6. And here, I skipped over my x term. So I'm going to have a 0x for that missing term. So I've got 3x cubed minus 2x squared plus 0x plus 6. You want to make sure you have every term accounted for. That's why I had to have that 0 in there. So to get from x squared to 3x cubed, I need to multiply by 3x. So do that multiplication. I have 3x cubed. I also need to multiply that 3x by all these other parts. So plus 0 x squareds, and then 3x times negative 3 would be minus 9x. I subtract those. So 3x cubed minus 3x cubed, those cancel. Negative 2x squared minus 0 still has me at negative 2x squared. 0 minus negative 9, when you subtract by negative, you're really adding. So this is plus 9x. And I drop down the plus 6. I go again. To get from x squared to negative 2x squared, requires me to multiply by negative 2. So I've got negative 2x squared plus 0x plus 6, because I had negative 2 times negative 3, that's what gave me that, plus 6. Subtracting those. Negative 2x squared minus negative 2x squared, those cancel. 9x minus 0x still has me with 9x. And then 6 minus 6 cancels to give me 0. So here, my remainder is just 9x. So my quotient for this problem is going to be 3x minus 2 plus my remainder goes on top of the fraction with what I was dividing by in my denominator. Now, questions 1 and 2 are different from questions 3 and 4 because questions 3 and 4, I do not have x squareds in those. So for these ones, because it's a coefficient of 1 and I do not have an exponent, that means I'm able to do synthetic division. So when I do synthetic division, in the box here is going to go the 0 from this. So if I were to say x minus 3 equals 0, what would x equal? Well, I would add 3 to both sides, so I would get x equals 3. So that is what goes into the box. And then I list the coefficients going down. Again, just like I did with long division up here, using a 0 anytime I'm missing a term. So I go from 3 x power 4s, but then I don't have any x cubes, so I need to put a 0. And then I have negative 32 x squareds, so I put negative 32. I have 17 x's, and then negative 6. When I do synthetic division, the first term just drops down. Nothing you need to do with it. That first one just goes down exactly as it is. Then you multiply what's in the box by that number, and you're going to put that product there. So 3 times 3 is 9. And then I will add those two values together. 0 plus 9 is 9. And then I go again, multiplying 3 times 9 to give me 27. And I add negative 32 plus 27 is 5. Negative 5, I should say, because of the negative. And I go again. 3 times negative 5 is negative 15. And I add those together. 17 plus negative 15, or 17 minus 15, is 2. Once more, 3 times 2 is 6. This goes up there. So negative 6 plus 6 is 0. This last term here is your remainder. Because it's 0, that means I do not have a remainder. It also means that x minus 3 is a factor of this because it divided perfectly with no remainder given. So to write this this quotient out now, I'd go 1 degree less than what I started. I started with a degree of 4, therefore this is going to be 3x cubed plus, and then for each following term just goes down by 1 degree on x. So plus 9x squared minus 5x plus 2. And I have no remainder, so there's no need for me to write one. For 4, it works the same way. What's going to go in the box is the 0. So what I'm dividing by is x plus 2. That would be the factor. So that 0 would be negative 2. And I list the coefficients going out. So I've got x cubed, so coefficient of 1, and then 3x squareds, coefficient of 3, 19 x's, coefficient of 19, and 34. Now on this one, I did not put a 0 anywhere because I didn't skip any terms. You only use the zeros when you skip a term, and it goes in place for that missing term. So the 1 drops down. I do negative 2 times 1. That is negative 2. And I add those. 3 plus negative 2, or 3 minus 2, is 1. And I go again, negative 2 times 1 is negative 2. 19 minus 2 is 17. I go again, negative 2 times 17 is negative 34. 34 minus 34 is 0. So again, I have a remainder of 0, which means that the polynomial x cubed plus 3x squared plus 19x plus 34, that one of the factors, if you were to factor it, is x plus 2. So this would be x. I started with a power of 3, so I go one lower to be x squared plus x plus 17. That would be your resulting quotient. Now for 5, 6, and 7, it wants us to, currently these are in standard form, and it wants us to put them into factored form. We have a lot of different methods that we could go about trying to do that. But the one that we're gonna utilize for this is putting these into your calculator to find the rational zeros. That way you could use that factor to do synthetic division. So for this, for number 5, you've got x cubed plus 3x squared minus 11x minus 33. So you need to graph that. So here is our graph. And we can't quite tell always where it hits, so we can look at the table. Whoa. My values are pretty far off. So let me go back to the center. Okay. So I have a 0 at negative 3, which is right there. Now this graph may look like it's tangent on that point, that it hits it and bounces back, but really what we have is slightly before it, it passes through, and then it's passing back through at negative 3. So I have a 0 at negative 3. So that's what's going to go into my box. So that way I can do the synthetic division to figure out how the rest of this is going to factor out once I remove that 0. So I have 1, 3, negative 11, negative 33. So doing the synthetic division, this 1 drops down. So I multiply negative 3 times 1 is negative 3. Add those, and it's 0. Negative 3 times 0 is 0. Negative 11 plus 0 is negative 11. Negative 3 times negative 11 is positive 33, giving me a remainder of 0. So this resulted in x squared plus 0 x's minus 11. Now, if I don't have any x's, there's no need for me to write that as being there. So I could just have x squared minus 11. Now this is not going to factor beyond x squared minus 11 if I'm wanting to keep it with real whole numbers. So x squared minus 11 is as far as it factors. However, I want to know what the whole thing is factored. So I need to include the factor that gave me that 0 of -3. So that factor would be x plus 3. Remember, a factor is what's in those parentheses where you have the x plus or minus, whatever else. A 0 is just what x equaled to give you a y value that is 0. Okay, looking at number 6, once again, you're going to put this into the calculator. So you're going to put in 5x cubed plus 22x squared minus 43x minus 204. And you graph it. And here's our graph. Now what we notice about this is I pass through 3 times, and when I look at the table, I have 2 rational zeros. There are 2 places that I can see that y equals 0. I've got 3 and -4. So that tells me I need to do synthetic division twice, once for each of those zeros. So I had a 0 at -4 and also at 3. Now it doesn't matter the order you do these in. You could do the 3 first and the -4 second. It really doesn't matter. So you need to put your coefficients out. So I have 5, 22, -43, -204. So the 5 goes right down. I do -4 times 5 is -20. 22 minus 20 is 2. -4. -4 times 2 is -8. -43 minus 8 is going to be negative, what's that, -61? 51. And then -4 times -51 is positive 204, giving me a remainder of 0. Now I need to do that one more time. Using the other known rational 0 that I had of 3. So the 5, once again, drops down. 3 times 5 is 15. 2 plus 15 is 17. 3 times 17 is 51. -51 plus 51 is 0. So this is the factor that I had left over. So I started with a power of 3. So at this point, it would have been starting with x squared. So here, I'm starting with just x. Since I did synthetic division twice, I lower the degree twice. So I've got 5x plus 17. But I also know these other 2 that gave me those zeros. I need to include those as factors. So I have x minus 3 and x plus 4. So once more, I have x to a power of 4 minus x to a power of 3 plus 3x squared minus 9x minus 54. And I graph it. So this graph once again, I have two places where it crosses, and both those places are at like rational numbers. So I have zeros of 3 and of -2. So once again, you're going to need to do synthetic division 2 times. It doesn't matter the order you do them in. You just got to make sure you do both of them. So I'm going to have 1, -1, 3, -9, -54. So this 1 just drops right down. 3 times 1 is 3. -1 times 3 is 2. 3 times 2 is 6. 3 plus 6 is 9. 3 times 9 is 27. -9 plus 27 is 18. 3 times 18 is 54. -54 plus 54 is 0. And I need to do it a second time with the other 0 that I know of -2. So the 1 drops down. So I have 1. -2 times 1 is -2. 2 minus 2 is 0. -2 times 0 is 0. 9 plus 0 is 9. -2 times 9 is -18. Plus 18 gives me 0. So I did synthetic division 2 times, so I'm going to drop the degree twice. So this is 1x squared plus 0x's plus 9. Since it's 0x, I don't need to write that. So that's x squared plus 9. Now, this is not going to further factor to have real and whole numbers. While both of these are squares, this is a sum of squares, and that does not factor out. So I've got x squared plus 9, but I also need to include these other factors. So I have x plus 2 and x minus 3. Close that parenthesis off. Now 8, 9, and 10 are different from 5, 6, and 7. 5, 6, and 7 just want you to factor it. So it wants you to stop right here. You don't have to go any further. However, with 8, 9, and 10, it wants you to actually find all the zeros that would be given here, both the real ones and the imaginary. So for this first one, we could put it into the calculator for us, but we can also notice that this is an example of a sum of cubes. Because 27x cubed, that is if I had 3x that had been cubed, so my a value is 3x, and 512 is if I had 8 that had been cubed. So my b value is 8. This is where we had our SOAP. So I had a, 3x, the same, since I started with addition, this needs to be addition plus b, which is 8. And the other factor is going to be 9x squared minus 24x plus 64. Now, what I'm trying to do is I'm trying to find the 0, so I need to set and say that this equals 0. So that means either 3x plus 8 equals 0, or 9x squared minus 24x plus 64 equals 0. Starting with this one's rather easy. We just subtract 8 from both sides. So I have 3x equals negative 8, and then divide both sides by 3, where I get x equals negative 8/3. This other one requires a bit more work. We need to use the quadratic formula. Remember, in our quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. My a, b, and c come from this quadratic trinomial. A is the coefficient on x squared, b is the coefficient on x, and c is my constant. So I have negative b, so b is negative 24, negative of that would be positive 24, plus or minus the square root of b squared, so that is negative 24 times negative 24, which is 576, minus 4 times a, which is 9, times c, which is 64. All of that is divided by 2 times a, so 2 times 9, which is 18. Now I do need to simplify this, so I have 4 times 9 times 64, which is 2,304. So I have 576 minus 2,304, which gives me negative 1,728. I've got 24 plus or minus the square root of negative 1,728 all over 18. When I am trying to simplify this, when you are doing your sum or difference of cubes, you will always be left with a remainder under your root. So you'll have a radical of 3. So you can do 1,728 divided by 3. That's going to be 576, which we just set up here. That is 24 squared. So what I have is 24 plus or minus 24i. The I came because it was the square root of a negative number. Square root of 3 over 18. And I need to simplify. All of those are divisible by 3. So I've got this ends being 8 plus or minus 8i square root of 3 over 6. Well, I guess that can simplify further. Because all those were divisible not by just 3, but by 6. So it's going to be 4 plus or minus 4i over 3. And that gives me all of my roots. 2 imaginary, 1 for the plus, 1 for the minus, and 1 real one right there. So looking at 9, we can start this by putting it into our calculator. So I have 5x cubed plus 22x squared minus 43x minus 204. So I am able to find in here real zeros at -4 and at 3. So from those, I already know 2 of my values. X equals -4 and x equals 3. To find my other one, I'm going to need to do synthetic division using those 0 values. So I have -4 goes in the box, and I have 5, 22, -43, -204. I'm going to have to do it a second time using the other 0 that I know, so I can set it up already. The 5 comes right down. -4 times 5, -20, giving me 2. So that's going to be -8. So that gives me -51, which gives me +204, a remainder of 0. And I go once more. The 5 comes down. 5 times 3 is 15. To make that 17, 3 times 17 is 51. To make that 0. So this is the other factor that I had, 5x plus 17. I want to know what value for x would make that equal 0. So I need to subtract 17 from both sides. 5x equals -17. And then divide both sides by 5. And x equals -17 fifths. And that's going to be my other 0 value. On this one, I put it into the calculator. I've got x to the power of 4 minus x cubed plus 3x squared minus 9x minus 54. I graph it. And here, I'm only shown 2 roots. Both of them are rational. I've got -2 and I've got 3. So I know those 2 zeros. So I can say x equals -2 and 3. So I need to do synthetic division to figure out the other zeros that I'll have here, but I know they're going to be imaginary because my graph only crossed twice, but I have a degree of 4, meaning I need to have 4 total roots. I have 2 real ones, so the 2 are going to be imaginary. I've got -2, who's going to go in the box, and then +3. So I'm going to have to do synthetic division 2 times. Across here I have 1, -1, 3, -9, -54. The 1 drops. -2 times 1 is -2. -1 minus 2 is negative 3. Negative 2 times negative 3 is positive 6. 3 plus 6 is 9. Negative 2 times 9 is negative 18. Negative 9 minus 18 is negative 27. Negative 2 times negative 27 is 54, giving me a remainder of 0, which I should get when I'm doing these synthetic divisions on these to find the factors, because I already know their factors, therefore they should divide in perfectly. 3 times 1 is 3, negative 3 plus 3 is 0. 3 times 0 is 0, so that's going to give me 9, and that gives me 27 to give me a factor, to show that that is a factor, so I have a remainder of 0. So this is x squared plus 9, and I just set that equal to 0 to solve it. For this, I can do the square root method, where I subtract 9 from both sides. So I have x squared equals negative 9. And then to get rid of a square root, to get rid of a square, use square root both sides. So I have x equals, when I choose to take a square root, I need to take both the positive and the negative. And when I have the square root of a negative number, I know that's going to give me I. That's going to give me that imaginary part. So then I'm just carried about, what is the square root of 9? Well, it's 3. So my additional x values are positive and negative 3i. So for 11, we are told that we have a double root at negative 3 and a single root at 5. So we can start just with our equation of that. So I have y equals a double root at negative 3. Well, the factor there would be x plus 3. To show I have a double root, or a root with multiplicity of 2, I square it. And then a single root at 5, so that factor is going to be x minus 5. But I'm also told that it goes through the point negative 7, 48. So there needs to be some stretch or shrink of what value I don't know. That is what I'm trying to find. I'm trying to find the a value. But what I know is that negative 7 is an x value and 48 is a y value. So I can replace those x's and y's with that information. So what I have is 48 equals, I still don't know what that a value is, so that stays an a. But my x value is negative 7. So I have negative 7 plus 3 squared, and negative 7 minus 5. Now I only am dealing with one variable, so I can just go solving for a. So I have 48 equals a. Negative 7 plus 3 is negative 4. That's going to be squared. And negative 7 minus 5 is negative 12. Well, negative 4 squared is positive 16. So 16 times 12, 16 times negative 12 is negative 192. So I have 48 equals a times negative 192. So I need to divide both sides by negative 192 so that my a value, a equals 48 divided by negative 192. Which gives me negative 0.25 or negative 1/4. So I already know the factored form of it. All I need to do is, instead of having a there, put that a value. So my equation is y equals negative 1/4 x plus 3 squared times x minus 5. 12, 13, and 14 are giving me the roots and wanting me to write the equation. So to start, I need to get it in factored form. So I have a 0 at negative 4, so that factor is going to be x plus 4. I also have a 0 at positive and negative 3 root I. So that factor is going to be x plus I root 3 and x minus I root 3. When you're dealing with these, you just FOIL it. But we want to start with the pair always. So I'm going to FOIL that pair first. X times x gives me x squared. X times negative I root 3 gives me minus xi root 3. I root 3 times x gives me positive xi root 3. And I root 3 times negative I root 3 is going to give me negative I squared square root of 9. These xi root 3's cancel each other out. So I have x squared minus I squared square root of 9. Well, the square root of 9 is 3, and I squared is negative 1. So I have x squared minus negative 1 times 3. Negative 1 times 3 is negative 3. So this is I squared minus negative 3, or I squared plus 3. And then I need to FOIL that with this other one that I had of x plus 4. So when I FOIL that, x times x squared is x cubed. X times 3 is 3x. 4 times x squared plus 4x squared. And 4 times 3 is plus 12. Now all you need to do is just rearrange so that you have it in standard form where your coefficients are descending. So I have x cubed plus 4x squared plus 3x plus 12. So that is that equation. Here we've got zeros of 4, negative 4, 5i, and negative 5i. That's going to be x minus 4 as a factor, and an x plus 4 as a factor. X minus 5i as a factor, and x plus 5i as a factor. FOIL your pairs first. So x times x gives me x squared, x times 5i plus 5xi minus 5xi minus 25i squared. I squared is negative 1. Negative 1 times negative 25 makes that plus 25. Those cancel out. So I've got x squared plus 25. FOIL these. X times x is x squared. Then I have minus 4x plus 4x minus 16. Those cancel. So what I've got is x squared minus 16. Then I would need to FOIL these. X squared times x squared gives me x power 4. X squared times 25 plus 25 x squared. Then minus 16 x squared. And then negative 16 times 25 minus 400. Combine like terms. I've got x power 4 plus, what is that, 9? Yeah. Plus 9x squared minus 400. So the equation that would give me those roots would be y equals x power 4 plus 9x squared minus 400. Our last one that we have, we've got 2, so that factor is going to be x minus 2. Square root of 7, so that factor is going to be x minus root 7. And negative square root of 7, so that factor is going to be x plus square root of 7. Starting with your pairs, x times x is going to give me x squared plus x root 7 minus x root 7, then minus the square root of 49. Those x root 7s cancel. So I have x squared minus the square root of 49 is 7. And I need to multiply that by that x minus 2. So I FOIL that. And I have x cubed minus 2x squared minus 7x plus 14. Making sure that it's the equation. I have y equals in front of it. Okay, so the big thing in all of this is, remember to do, if it asks you to solve, do the synthetic division and then solve it for x. If it wants you just to factor, do the synthetic division and just stop. Do not go any further. If you have a coefficient or an exponent on x in what you're dividing, you have to do long division. If you do not have an exponent and your coefficient is just 1 when you're dividing, then you can do synthetic division. And when you have ones like number 11, use the information that it's given you to find out what the equation would normally be, and then use that other point to get the x and y values so that you can solve for a and find your end equation.